All right, so I'm going to title my page because it is geometry today. Thank you. So geometry, and we are officially starting Unit 1. Unit 1. And these will be titled as our Day 2 notes. We are on the second day of geometry now. So, because we didn't really have any notes yesterday. Day 2 notes. Okay, and if you are somebody that likes to match your notes or make sure that they're consistent in a certain way, the way I'm titling these notes today is exactly how I will always title them, so I can keep myself organized. Feel free to copy how I'm doing it, but also if you have your own method, it's okay if you don't do it exactly the same way. I just know some students really like to try to make it really similar to how I do it. So I'm also going to number my pages. Page 1, and today is Tuesday, August 5th. Yes, thank you. Tuesday, August 5th. Okay. So, we have been measuring line segments. What we have not been measuring is lines. You might be thinking, what's the difference between those two? Well, there is a difference. So first, we're going to talk about the definition of a line. A line, now these next few definitions I'm going to explain a little bit, but I think sometimes in geometry the best way to define something is to draw a picture for it. So make sure you've got your rulers out because we're going to want to draw some straight edges. And for your line, we are going to draw, and I'm going to do about let's do 3 inches here, about. I'm going to draw a 3-inch long-ish line segment. Now what makes this a line is we're going to put arrows on the ends of each end there. A line is something that actually goes on and on and on and on forever to infinity in both directions, opposite directions. So a line never ends, ever. That's what those arrows represent. So if you want to put a little definition beside that, you don't have to, but some people like to. I'm just going to say goes on in both directions forever.
And it'll always have arrows, yeah?
Yes, always. If it does not have arrows, it is not a line.
It's a line segment.
Yes, yes. So if this is a line, can any of you kind of guess what a line segment would be considered? Yeah, they've got endpoints. A line segment is a piece of a line. So when we say draw a line, you gotta have the arrows. Now I'm gonna say it wrong at some point because line segment, you're gonna forget to say the word segment. But when we're getting technical, a segment does not go on forever. There are defined endpoints. So now I'm gonna write line segment. Segment. I need a new marker. This one's about to run out of ink. Let me pause that. All right, so let's finish that. Line, S-E-G-M-E-N-T. Yeah, that's actually perfect. Line segment. So in simple terms, a line segment is a piece of a line. It's a chunk of a line that we took off. So we're going to draw a line segment now. I'm going to do the same kind of thing here. I'll make my line segment about 3 inches. You don't have to do it the same, but that's just what I'm doing. 1, 2, 3. And to show that this is a segment, technically I could just leave it like this, because since there's no arrows, this does not go on forever. The arrows are what says it goes on forever. But just to make it a little more obvious, I'm going to draw end points. End points. I'm also going to label my end points so that we can remember that that's what these are called, end points. It's the points at the end of the segment. So, end point. And for definition, I'm going to write a part of a line or a section. I'm going to say a section. That sounds more like segment. A section or part, I'll do both, of a line with end points. So we know what a line is. We know what a line segment is. The next item is a mixture of the two. I'm going to start by writing this word, and I bet some of you may remember this from way back in the day. I remember learning about this in about 5th grade. But I always love to review the basics because I'm not going to start saying words and assume you know them if it's been a minute. Ray. Do any of you know what a ray is? Yes.
A line that starts and continues on in one direction.
Yes, yes. A ray starts with an endpoint and then it continues on forever in one direction. Beautiful. So we're going to draw a ray. We're going to start this time with an end point. Then we will draw a line, and we need to put an arrow on the other side. This is a ray. One end point, one end goes on forever. So I'm going to write one end point and one never-ending line, essentially. It's a mixture of a line and a segment. Now the best way to remember ray, this was my favorite way of remembering, is it's like the rays that come off the sun. Because the sun is like our big end point here. This is kind of our point of origin, and the rays that come off of the sun, they go on forever and ever, don't they? This is our end point. These are our rays that come off. Kind of cool. Little tricks that help. So that's a ray. And the final term I'm going to give you that I'm sure you've all seen and heard and know is an angle. We're building on it. An angle is made up of two rays. So, I'll give everybody a second to kind of catch up on the notes, and then I'm going to give you some more specifics on the angle. When we draw an angle, we're going to start with a ray. So I'm going to start by making an end point, and I will draw a line coming out of that end point with an arrow at the end. And as it stands, this is just a ray, but it becomes an angle when we add another ray that comes off of the same end point. They have to share that end point. And whenever we add this next ray on the same end point, this end point gets a new name. It is no longer an end point. Does anybody know what this point would be called in an angle? It's a real out of left field word. Ooh, this would be an acute angle, yes. Not the name of this point. It's, as soon as I say it, you're gonna be like, oh my god, I knew that. Vertex.
Oh.
A vertex. And it's easy to remember because it makes a V, vertex. So that end point is no longer an end point. When it is part of an angle, I'm going to circle that, and now it is the vertex, V-E-R-T-E-X. And on the inside of our angle, we will draw this. This is an arc. We can label that as an arc as well. This measures the angle. We'll talk more about that later. And if we want to define an angle, we could say two rays that share a single point. And then in parentheses, I'm going to write that new word, vertex. Okay, so we've got all these definitions, and then we're going to talk about them. So I'll pause this and let everybody get a little caught up on that. All right, so we have all of these definitions. We know what a line is. We know what a line segment is. We know what a ray is. We know what an angle is. I would now actually like to go into different types of angles. We're really going to go into classifying things today and making sure we know how to name them. So I have this much space on my page left, and what I'm going to do is I am going to create 3 little sections here. And let me see how large this is. We have about 8.5 inches. 8.5 divided by 3. What would that be? 8.5 divided by 3. About 2 8/10 of an inch. Almost 3 inches. Okay, let me just make some little markings here. 1, 2, okay. This, close enough. All right, so I'm gonna make 3 little sections here because I am gonna talk with you guys about 3 types of angles that we will see. Now, this is where you mentioned acute. That is one of our angle types. Technically there's 4 types, but we'll get into the 4th type a little bit later on. So here's my 3 sections, and we're going to title these sections. The first section we are going to write acute angle, and it's spelled just like it sounds, A-C-U-T-E. A-C-U-T-E. And instead of writing the word angle, I'm going to teach you the symbol so you don't have to write it out so much. And the symbol, instead of writing angle, just looks like a little angle. You're going to draw what looks like a angle and then put a little arc in it, like that. So this says acute angle. After acute angle, my middle section, I'm going to write right angle, R-I-G-H-T, right angle. And finally, we have the last one, which is obtuse angle. So 3 angle types. Does anybody know what makes an acute angle an acute angle? 90 degrees? Less than 90. Ooh, yes, yes, it is less than 90. The 90 is the basis though, so it's good that you have that number in your head. So an acute angle is an angle that is less than 90 degrees. Now, what is a 90-degree angle? Let me pause this and grab some measurement tools for you guys, and we'll look at that a little more visually. Okay, so each of you should now have a protractor. What I want you to do is to make sure first that your protractor is facing like this. The flat side should be on the bottom. Check the 90. Make sure it says 90, not 09. Make sure it's not upside down. Now, I'm going to pull a different piece of paper out just to demonstrate this, and you're welcome to do this too, but it does not necessarily have to be part of your notes. We're going to start with a ray. Good morning. Let me pause real quick. Okay, so on this separate sheet of paper, what we're going to do is we're going to start by drawing a ray. So I'm going to create a point, and I'm just going to draw a straight line coming out of that. And I want it to be somewhat long of a line. I'm making mine almost 5 inches. It's not perfect, but you know. And what we're going to do with this ray is we're going to take our protractor and we're going to line it up on the ray. So above the 3 at the bottom, you'll notice there's a little hole. We want to put that hole right on the point. And we want to line everything up nicely. Now, we want to check both ends here. You're going to notice these protractors are not perfectly accurate. Wherever you put this point, these little edges tend to be a little lower. It's fine. It's what we have to work with, so we're going to make it work. Now, you will notice over here by the ray, there's 2 sets of numbers on your protractor. There's numbers that start on the inside of this circle, the semicircle, that start with 10, 20, 30, 40, 50, 60, 70, 80, 90. Then there's numbers on the outside of the semicircle that start with high, 170, 160, 150, 140, 130, blah, 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 blah. Because we are starting on the right side, we're going to count up from the ray. Does it make more sense to count up 10, 20, 30, 40, 50, or to count backwards 170, 160, 150? Which one makes more sense? Count up. So should we use the numbers on the inside to measure or the outside? The inside. We're going to use the inside numbers since we're starting from 0 here. It makes more sense to go from 0 to 10 than from 0 all the way to 170. So I am counting up here to 90. Okay, so 90 is our kind of middle measure that we're going to use as a basis for all of our angles. What I would like you to do is make sure again that your vertex is lined up real nice onto that circle, and we're going to make a mark where that 90 is. So I'm going to put a little mark right there under the 90. You could also put a mark above it if you like. Technically, you could also put it in this. There's another hole right there. So up to you. When you take that away, here's what you're left with. What we'll do next is connect this point to the little dashes we just drew. And we're going to have a perfect 90-degree angle. There we go. So, ignore that, that little extra thing. But this is a perfect 90-degree angle. Now, to show that this is a 90-degree angle, we put on the inside here, instead of an arc, we're going to put a little box. The reason for this is in a shape like a square or a rectangle, a boxy shape, all of the angles are 90 degrees. So we just complete that box by putting the other angles in. This always means if there's a box, it's always a 90-degree angle. Always, always. So we're going to flip back to that note page. Unless, does anybody still need to see this? Everybody good? Okay. So right here, what we just drew is a 90-degree angle. An acute angle is less than 90. An obtuse angle is going to be more than 90. A right angle is exactly 90 degrees. So what we're going to put under right angle is an angle that is exactly 90, and degrees is that little circle up here like that. An angle that is exactly 90 degrees. And then we're going to put a little picture in here. Doesn't have to be perfect because your protractors are going to be tough to draw with in such a small space, depending on how you laid out your notes. So what I'm going to do is just kind of guesstimate. I'm going to draw a line pretty close to straight up and down, and another one over here. And to show that it's 90, we draw that box inside. So this is a right angle. It's exactly 90 degrees every single time. So once you've got that, we can fill out definitions for the other ones. I'll start with acute. An acute angle is an angle that is less than 90 degrees. An angle that is less than 90 degrees. Now, it doesn't matter how much smaller than 90 it is. If it's 89.9999999, it's not 90. It's less than 90. So even just the tiniest bit smaller, it is an acute angle. And I always remembered acute because in the name it says it's acute. It's a cute little angle. It's a little baby. A cute one. And it's cute because it's less, it's smaller. Another student told me that what they do to remember acute is they see that the word cut is in it, cut, and an acute angle is like a pair of scissors that you cut with, because see that? It's like less than a 90-degree angle. So, two little tricks to help you remember. So, if a 90-degree angle, we went up to 90, less than 90 is going to be lower than that 90. We would draw a dash mark closer, somewhere on the 80, 70, 60, 50, 40, 30, 20, 10, as small as you want it to be. I'm going to start with a straight line or a ray. We're going to draw a picture right here. And all we have to do for it to be considered an acute angle is don't put that next ray straight up and down. Just tilt it over a little. So I'm going to put mine right about here. Oops. Okay. So this is an example of an acute angle. And we'll put an arc inside.
Does it matter where that arc goes?
Where would it go if it wasn't here? Do you mean like make it smaller
Like
or
goes
bigger?
Smaller or a tiny bit larger? Like is there an exact spot that it needs to go?
Wonderful question. No. You could make it real big if you want. You could make it teeny tiny if you want.
Okay.
It just shows which way the ray is rotating. So you could have this acute angle, but you could also say I started here and opened up so far that it is that way if you drew the arc on the outside. But we're just looking at inside angles today. That's a great question. Okay, now an obtuse angle is an angle that is more than 90 degrees. It's bigger. An angle that is more. Could be 91 degrees. Could be 160 degrees. Could be any number bigger than 90. More than 90 degrees. Now, an obtuse angle can sometimes be a little bit trickier to draw because sometimes we underestimate the amount of space we need to draw it. The one tip I will give you is when you do draw the obtuse angle, don't start your point too far over or it's going to go into the other, it's going to go into the right angle section. We're going to start right about in the middle here. I'm going to create a little point for myself. And I'm going to draw a ray coming out that way. So a little bit of a smaller ray to begin with. Now if it was a 90-degree angle, it'd be straight up and down like this, right? If it was acute, it would be less, so we'd be tilting it this way. For obtuse, it's more, so we're tilting it outwards and we're creating a big angle like this. There we go, and then we'll draw a little arc in there as well. That is your obtuse angle. Alright guys, so we have our different angles labeled, we have them drawn, we've got some definitions out, and we're going to do some things here in a bit with these angles, with these lines, with these segments. We're going to start using some actual numbers and math things. But until then, I'm going to leave my notes out for anybody that needs to catch up on that. And I would like for you guys to take a little break. Take a break. You are welcome to stay in here. You're welcome to leave the room and come back. I'm going to give you guys 15 minutes. So I'm going to say it'll be about 10:18. We'll start back up. So I'll put that on a sticky note. But yeah, take a little break. Take a breather. Okay, we are back from our break. And I just passed out this worksheet to you all. We're going to go back to the segments. It says solving for X, segment addition postulate. That's a lot of things. I haven't taught you this yet. I'm about to. So, putting this to the side, let's take a few quick notes and go over some examples using this worksheet. Because now we know what a line is, we know what a line segment is, and all of that good stuff. So, I'm going to start one more little page of notes here, and I'm going to title my page, let's see, This is Geometry, Unit 1. This will be page 2 of our notes. And it's day 2, notes continued. Okay. So, first of all, you might notice the word postulate on this worksheet. Postulate. That is an interesting word. Do any of you know what postulate means or what a postulate is?
It's a basic rule that you believe is true or something like that.
Girl, you almost got that word for it. A basic rule we accept is true.
Yeah, I'm good at
Literally.
vocabulary.
Yes. Yes, a postulate is basically a rule in math or in other things that thousands and thousands of years ago somebody came up with. They told us it's true, so we're just going to accept it's true, okay? We don't need to spend too much time worrying about why it's true. That would be a different kind of class. So, a postulate is just a basic rule that we accept as true. And we're going to be talking about the title of this worksheet, which is the segment addition postulate. We know a line segment is a piece of a line, addition is adding, so we're going to talk about the rule that happens whenever we add together line segments and they're compared to another line segment. So let's write down as well that name. I'm going to write segment addition postulate. Segment addition postulate. Okay. Now, there's a definition for this technically. Hang on. Pause. To that segment addition postulate. The definition for this is a little bit wordy. If you don't write it, it's okay. But I am going to write it for you if you are somebody that likes to have definitions. And before I give you that definition, I'm going to draw a picture. Let's do this. I'm going to draw a line segment with endpoints, and somewhere on that line segment we're going to draw another point. It doesn't have to be in the middle, just somewhere on that line. And we are going to label these points A, B, and C. Let's see. I'm going to use orange. A, B, C. So, the definition of this segment addition postulate says if point B, let's see, if point B is between point A and point C, then and I'm going to show you a new way of notation, a new way to write something. I'm going to write AB with a line over the top of it. This is how we name line segments. So the line segment AB means just this piece from A to B. Yes, yes, you got to put that line above it too. Great question. Yes, put the line above it. AB plus BC, the line segment BC, with a line over it.
Equals
Yes, yes, you already know it. Equals A to C. So A, C. Exactly, with a line over it. So basically, if there is a point that is in the middle of 2 points, if there's 3 points, the first 2 points plus the second 2 points equal the first to the last. It's, you know, 2 parts make the whole. This is a very wordy way of putting it. I think it makes more sense to see it visually, but that's just me. I'm a pretty visual person. And I'm going to give you an example, because I think examples help demonstrate this best. So, I am going to draw I'm going to put a 1 here. This is the first example. I'm going to draw a line segment with 2 endpoints and a point somewhere in the middle. Let's see. Yes. I know. It is kind of scary because sometimes when I click that away, you just never know.
Yeah.
It's definitely happened before where I lost a whole lesson. And we're going to label these points A, B, and C again. A, B, C. And let's say that AB, the line segment AB, let's say this is 2 inches. So down here I'm going to write AB equals 2 inches. Now I'm going to say that from B to C is, I don't know, let's say 8 inches. BC is 8 inches. Could we solve for the line segment AC? And how would we do that? Just add 8 and 2. And why can we do that? Does anybody know? Why are we just going to add these two together? Why does the 2 inch plus the 8 inch give us the length of A to C?
Because it's the whole length of the line, right?
Yeah, it's the whole length of the line segment. AB plus BC equals AC, according to the segment addition postulate. It's a rule. We accept it's true, so we can use it over and over and over. Because B is in the middle of AC, we can use this. So I'm going to write here, well, I know that AB plus BC equals AC. And well, AB is 2 inches. So I'll replace, we're going to treat this like a variable. You guys remember what a variable is? A variable is just a letter or a symbol or something that represents or replaces a number. Very good. So AB over here, we know it's 2. So I'm going to write 2 inches plus, what's BC? 8 inches. Good. 8 inches equals 10. So AC is 10 inches. And that's your answer there. Very nice. Now this is a more simple one. Sometimes it helps to visualize what's happening by labeling your drawing. So I might write on top of AB 2 inches. I might write on top of BC 8 inches. Then for me, this makes more sense. Some of you might look at this and say, well, I got it. That's nothing. This helps me a lot. So it might help you. Seeing that those two together do add up to 10 inches. Okay. Let's look at another example, but this time I'm not going to give you both of the small parts. Let's use some different letters. How about QRS? QRS. And I'm going to connect those. Okay. And let's say QR, we don't know. I don't know the length of Q to R. I know that RS is 12 inches. And let's say that I know also that QS is 40 inches. You just subtract 12 from 40. How do you know that that's going to work? I know, the explaining part's the hardest part.
Because 40 is it as a whole.
Yes.
So if one part is 12 inches, then the other part is going to be whatever the difference is between.
Yes, yes. Oh, that was a beautiful explanation. So basically what she just said is we know that the whole segment from Q to S, and I'm going to label it, kind of draw on here. I know that from here to here is 40 inches. Okay. We also know that RS, this little segment here, is 12 inches. So let me get a different color here. From R to S is 12 inches. So to find QR, we're just finding the difference. If the whole is 40, we take away that 12, whatever is left is our answer. So what is it?
28.
28. Okay, so let's set that up. This is where we are leaning towards writing an equation, because if we wanted to, I could say, we could call a QR, we could keep calling it QR. We could also call it a single letter like X, unless that makes it more confusing. So I could say, well, X plus 12 is 40. Those two wholes, or those two parts, make the whole. I could say X plus 12 equals 40. I know, I have no computer safe.
You have one back.
Thank you.
I don't know how Jenny got it from you, but you got it.
I appreciate it. So I have X plus 12 equals 40. Now, you could be able to look at this, because this is a slightly more simple problem, where exactly what you just said, we just do 40 minus 12. If I wanted to set it up as an equation, this can show us where that minus 12 comes from.
And you want to combine like terms.
Uh-huh. Yes.
And you want to always get the variable equals.
Yes. So remember, this is way back to algebra. Always good to review. I have an equation, X plus 12 equals 40. Well, I want to get X equals something. So we got to get rid of that plus 12. Minus 12. Whatever I do to one side, I have to do to the other side. Minus 12. Okay, my 12s, what happens with these? They cancel out. Good. I will bring down my X equals 28. Beautiful. So that is one way to do it as well. So QR, because we said that this is X, 28. There we go. Okay, now, does this make sense to everybody? Do we see what happened there? Or is it a little fuzzy? Okay, it looks like you guys got it. You guys are smart. Okay. Let's make it harder. Let's now move to this worksheet. Okay. And well, here, I'll give you guys a second. I just wrote a lot of things and I'm moving on quick. Let me pause it, give you a minute to catch up. All right. Let's look at this worksheet. Oh my gosh, this looks scary. It might not look scary to you. If it does, that's okay. I'm gonna try to help it not feel so scary. If it doesn't look scary, then awesome. Awesome. So this is using the segment addition postulate. We just did some examples with simple numbers. Now we're looking at something a little more complex. So here's what is happening. Here's how they label things. We have H, G, F. I know that from H to G, we have 2x plus 20. Okay. From G to F, 7. And this at the bottom, where they do a line and then 2 kind of stoppers on the ends, this is telling you the length of the whole segment, HF. They just have it labeled a little bit differently. So we'll run through this first one together. If it helps, maybe color code, do some labeling if it helps. I'm going to say HG is 2x plus 20 because that is how it's labeled, 2x plus 20. GF is 7. GF.
So if you were setting this up as an equation, wouldn't it be 2x plus 20 plus 7 equals x plus 20?
Yes, exactly. You've got it already.
You weren't good at math.
Like you know it before I teach it.
Perfect score in algebra. Once I got the algebra 2 in geometry, I was like, nope.
Well, and I'll tell you what, you'll like
You're
this.
killing it.
You'll like this unit because this unit is algebra heavy. We're doing a lot
Well,
of
I'm really good
equations.
at algebra, but like everything else beyond algebra.
Well, you'll do great in here. You'll do great. Okay, so I have HG is 2x plus 20, GF is 7, and HF, the whole length, is x plus 20. Now, if writing all this out makes it more confusing for you, don't write it all out. You can do math. This is the beautiful thing about math. You can solve a problem in about 2 million different ways and get the right answer every time. As long as you're following the math rules, you don't have to do it the same way I do it. If you have a better method, I love hearing those methods. So you could label it, write it out. You could also say visually, okay, well, I know HG, 2x plus 20, add that to 7, it's equal to x plus 20 because that's the same length of all of it. So let's write an equation. I know HG plus GF equals HF. HG is 2x plus 20. So I'm going to write 2x plus 20. What should I write next? What am I adding to that? 7. Good. Plus 7. And that is equal to x plus 20. Good.
And then you combine the like terms.
Yes. Now, before we go forward, does anybody need a refresher on what like terms are? When I say combine like terms, do we know what that means? Be honest with me. Is there anybody that's like, I'm not 100% sure? That's okay if you're not. Okay, thank you for that. So, like terms, quick side note, all of you have sticky notes at your table, so if you ever want to make a side note of something, you're welcome to use sticky notes. I usually do this if it's something that's not part of the lesson, but a side note. So, like terms are numbers that are attached to the same variable or exponent. So, for example, 2x and 5x. Are these like terms? Yes, they are like terms because they both have x. So we can add them together and make 7x. Good. So these are like terms because of the x's. What about 4y minus 2y squared. Are these like terms? No, why not?
Because it's 2y to the second power.
Yes, if there is the same variable, you almost have like terms. The reason these are not like terms is this y has an exponent on it. They have to have the exact same variable, exact same exponent. So these are not like terms. Okay, so whenever we say we're combining like terms in an equation, we're looking to see, for example, I have 2x. Do I have any more terms with x? I do, right here. So we're going to put those together. We need to get all the x's together on the same side. So I'm going to move that over. And let's see now. If I want to combine 2x and x, I have two different options. What are some things I could do here?
Subtract the x from the right side.
Yes.
And subtract the x on the two.
Yes, and that's what I would recommend doing. Let's get them on the same side. Let's go ahead and subtract x from this side. And remember, whatever you do on one side of that equal sign, you have to do it on the other. So there's my little dotted line. I did it over here. Oops, I gotta do it over here. Minus x. Okay, so what happens now to these x's?
They get pulled down. That one gets pulled down and then that one gets canceled.
Okay, these get canceled. If I start with x, I take away x, guess what? There's nothing left. No x, nothing.
You're left with 20.
Yes, so on this side, we have 20 that gets brought down. Nothing else, so I'll bring down my equal sign. And over here, now what happens?
Your 1x comes down.
Yes, 2x. I take away one of the x's. Now I have 1x. We don't have to write the 1. We can just write x. But if it makes you more comfortable, you can write 1x. But I'm just going to write x. If anybody's confused about that, stop me.
And then wouldn't we just combine 20 and 7? Just make
Yes,
27?
you totally can. Hang on. So 20 and 7 are both just regular numbers. Technically, we could combine them at this step, and instead of bringing down x plus 20 plus 7, we could bring down x plus 27. Is anybody uncomfortable with that? Can we do that? Okay, let's do that. So I'm going to combine these. 20 plus 7. 27. So now I have x plus 27 equals 20. What would I do now? I'm trying to solve for x.
Subtract 27.
Yes, subtract 27 from both sides. So minus 27, minus 27. What happens to my 27s? They cancel out. So I'll bring down my x equals, what's 20 minus 27? Negative 7. Good. And that would be our answer. So circle it. Get in the habit of circling your answers, because when we're doing lots of equations, there's lots of numbers. It really helps me when I'm grading to see your answers circled. Plus then it just makes you feel like, okay, I'm done. I can circle it, I'm done. So we're solving for x in all these. We're not solving for lengths. X is negative 7. If you wanted to find the lengths, we could plug that in, but I'm not asking you to do that. We're just solving for x. So that's the answer to number 1. Okay. Any questions about number 1? Okay. Are we ready to do number 2, or do we need more time? I'm going to take the silence as we're ready. Let's do one more together. Just make sure we feel good. And then I'm going to have you guys try some of these by yourself if you feel good about it. So, can I move this? Does anyone still need it? I'm moving it. Okay, number 2. I want to write an equation to solve for x. Sometimes it helps to color code. I'm going to say, okay, here's my 2x plus 20. That's one part. Here is my 8. So blue and red, and then blue plus red makes purple. So purple is the whole length. That's how I'm going to do that. What equation should I write here? How do I set these equal to each other?
2x plus 20 plus 8 equals 20 plus x.
Yes, 2x plus 20. That's this first small section. 2x plus 20 plus the other segment is 8. Oops. Equals the whole length of that large line. 20 plus x. Okay, so we have an equation. What should we do from here?
Combine like terms minus the x on the right side and the same for the left.
Okay, so we're going to combine like terms. I always like to start with the x's, so we're going to do that. Let me grab maybe a smaller pen. We'll see if this one works a little better. Okay, so we're going to subtract x. Get all the x's on one side. Subtract x again. All right, what happens to my x's? They cancel. And on the other side, 2x, take away an x, what's left? 1x, just an x. Okay. Now, what do I bring down?
You would bring down, well, combine 20 plus 8, which equals 28. So plus 28 equals 20.
Okay, so at this step, if you would like to combine these, the 20 plus 8, you totally can. That's 28. So I'm going to bring down below the line x plus 28 equals, what's left over here?
20.
Just 20. Good. Okay, last step. What do I do now? Minus 28. Good. Minus 28. And what happens to my 28s?
Okay.
They cancel. And what is 20 minus 28? Negative 8. So that is our answer for number 2. X is negative 8. Okay. Now before I set you guys off to do some of these on your own, do we have any questions? Is anybody totally lost? If you are, come talk to me later, okay? I want to help. So what I would like for you guys to do now is I'm going to pop over to Noel's room and see if I can help him with his board. But number 3, 4, 5, and 6, so the next 4 problems, I'm going to set a little timer, and I would like for you guys to try your best to do those on your own. Now, if you notice somebody in the room, like if you finish yours, you see somebody that is struggling, help each other, okay? This is, when you guys are working on worksheets in class, I am never upset about you guys helping each other. Collaborate, okay? This is only going to help you learn more. When you teach somebody else, you learn it better. And I'm sure your classmate will be thankful that you helped them. So, don't just give people answers. Help them through it. So I'm going to pause our recording, and I will set, let's say, a 15-minute timer. I want you to try to finish up to number 6. If you get past that, you can do more on the back. And if you don't quite get past there, that's okay. Just do what you can. But I'm going to pause this, and I will be back in a moment. All right, number 3. What answers did we get? Shout them out.
-1.
-1. Did anybody get something different than -1 for number 3? Everybody got -1? Okay, number 3. I guess it must be -1. X equals -1. Number 4. 6. Did anyone get something different than x equals 6?
I got
You got -6? X equals -6. Did anybody get something different than 6 or -6? Okay, so let's see. Let's see. I am going to write out this problem on a sticky note. First, let's see how we would set this up. How would I write this equation to solve for x? What would I start with here?
6 plus 2x.
Yes, 6 plus, what am I doing? 6 plus 2x minus 6 equals x plus 6. Perfect. Okay, so the first step we're always going to try to take is combine your like terms. Are there any like terms I can combine here? 6 minus 6. What happens when I put those together? 0. They cancel. 6 minus 6 is nothing. So we could, from the very get-go, cross those out. You could also, of course, add 6 to both sides and then subtract 6 from both sides, but that'll end up just canceling again. Okay, so what do I do now?
2x equals.
Yeah, let's just rewrite everything. Let's just bring it all down, make a nice, neat new problem. 2x equals x plus 6. So now, here's my new problem. What should I do next?
Subtract the x from both sides.
Subtract the x from both sides. Draw my line. What happens to my x's? They cancel. 2x minus x. What's that?
X
Just 1x. X equals, bring down the 6. So I believe our answer is x equals positive 6. If you got -6, yes, go ahead.
I think where I went wrong, because instead of when you add like terms at first with the 6's, I did it with the x. I minus x for minus 2x. Did that.
Okay.
I don't know if that's how I got the negative.
So let's see, if you do it that way, where you mess with the x's first, I want to write down what you had. So you had 6 plus 2x minus 6 equals x plus 6. That's how you started?
Yeah.
Okay, then you subtracted x from both sides, right?
Yeah.
Okay, minus x, minus x. Your x is canceled over here, right? And then 2x minus x, what'd you get? Just x. Perfect. Okay, then what did you bring down?
Then problem 6 plus x minus 6.
6 plus x minus 6 equals 6. Okay, then what did you do?
Then the next problem after I wrote down x plus 0 equals 6. So I did
Okay, that works. X plus, because the 6 and the minus 6 add up to 0. So x plus 0 equals 6. You could do that. Now, where did your negative come from?
I have no idea.
And that happens. That happens sometimes. Sometimes we just write things that don't make sense. That's all right.
I wrote the whole third problem wrong.
Yeah, it happens. No big deal. We're learning here, guys. You're going to get things wrong. We would never learn if you got every single thing right from the get-go. So we're learning things. It is x is positive 6. So if you didn't get that, it's okay. I literally just taught this to you today. It's brand new. So I'm going to cross out that -6 for number 4. It is x is positive 6. 6. Any other questions or comments on number 4? Okay, how about number 5? What'd you guys get for that? 3? Uh-oh, did you get -3?
Yeah.
Okay, so x is 3, x is -3. Anyone get something other than those? Did everybody get 3s? Okay, okay. Now we're certain, yeah, I got a +3 too. I'm gonna have to look and see what you're doing over there. I don't know. Maybe you could just be copying it wrong. I don't know. I'll look at your paper though. So number 5 is x equals 3, +3. How about number 6?
4.
4. Did anyone get something other than x equals 4? Oh my goodness.
When you're doing it, like subtracting from the other side, if it's a positive, are you subtracting and not adding?
I don't know, I gotta start writing the whole problem down, so I do like half of it in my head.
Yeah,
And that's
yeah.
It's confusing.
That's why.
And you know, one of the things that is the hardest part to teach and the hardest part to learn as a student is how to take your time with problems, because you get in the zone sometimes. You're like, yeah, duh, that's what this is. Okay, moving on. But it's in those moments that you make the silly, silly mistakes. Take your time. I would rather you take forever and get it right than speed through it and get it wrong. Now, even when we take our time, we sometimes make mistakes, but it's just a good practice to go slow with things. Okay, we got those? Any other questions? Concerns? Confusions? Okay, okay. Flip to the other side. I would like for you all, here's my thought, and I want to remind you all how these work. I'm going to make an exit ticket for you today so that you have plenty of time to work on it before you go. It is going to be a problem like this. One problem today. You can, if you finish it, you can show it to me. I can check it before you go. You can know how you did. Make corrections. If you don't want to show it to me before you go, or maybe you just want to turn it in and leave, it will be graded by tomorrow. It'll be in your folder, so you'll have the rest of the week to correct it and to learn from mistakes. So what I'm going to do, and how I normally do this, is I make the exit ticket right in front of you. A lot of students like to use this time to get their things together, maybe use the bathroom, get a drink, and then I take this to the copy machine and run copies for you. Some students like to write it out themselves so they don't have to wait for me to copy it. Up to you entirely. But I am going to pause this recording while I make it, and I'll unpause it when it's done. All right, here it is. The end.